For this example, we're going to look at an inverse variation problem. We have the intensity of light received at a source varies inversely as the square of the distance from the source. A particular light has an intensity of 20-foot candles at 15 feet. What is the light's intensity at 10 feet? So we have several parts to this problem. The first part is to just write an equation with the given information. So we're told something about the intensity of light received. So let's use a capital I for intensity. Well, we know the intensity of the light received at the source varies, so we're going to put an equal sign when we see varies. It varies inversely as something. When we have inverse variation, we put our constant k in the numerator, and whatever it's inversely varying with, we put down in the denominator. So it varies inversely as the square of the distance. So that's just distance squared. So we'll write d for distance, and we need to square that. So in step 1, we have our formula. I is equal to some constant k over d squared. Now in step 2, let's use the information we're given so that we can find k. The goal here is to find what k is equal to, our constant of variation. So let's plug in the information we know. A particular light has an intensity of 20 foot candles. So for I, we have 20 at 15 feet. So the distance d is equal to 15. So when we substitute those in, we're going to have 20 for I is equal to k over our distance 15 squared. So if we solve this for k, we get that k is equal to 20 times 15 squared, which is just 4,500. Now we've used the given information. So let's go on to step 3, and let's just simply rewrite step 1, but let's put in the constant k that we know is 4,500. So we have I is equal to 4,500 divided by d squared. And now in step 4, we're ready to answer our question. The question is, what is the light's intensity at 10 feet? So we want to know what the intensity equals when the distance d is equal to 10 feet. So we substitute 10 in for d into our equation in number 3. So we have I is equal to 4,500 divided by 10 squared. So that's just 4,500 divided by 100. So our answer would be that the light's intensity would be 45, and in this case it would be foot candles.